Students, this is Dr. Mohga, and today we're going to be solving paper 6 for October-November 2024. Figure 1.1 represents a stack of glass microscope slides. A student takes measurements from a stack of glass microscope slides in order to estimate the number of slides in the stack. The sides of the stack have been covered with tape so that the student cannot count the number of slides in the stack. Figure 1.2 shows side views of the taped stack of slides given to the student. This figure has been drawn at full scale. Okay, so I can see the length, I can see the height, I can see the width. Using figure 1.2, measure the length, width, and height of the covered stack of slides in centimeters to the nearest millimeter. Okay, nearest millimeter, so we're talking about 1 decimal place. I already have done that using my ruler, so please use your ruler to measure the length, width, and height. So the length was 7.5 centimeter, the width was 2.5 centimeters, and the height was 1.3 centimeters. The student uses a balance to measure the mass m of the covered stack of slides. Write down the mass m of the covered slides to the nearest 0.1 grams. This is easy. 0.1, so here I have 8, and the number above it is 7. As we agreed before, any number which is 5 or more will add on to the one before. So in my case, it's 57.87. 7 is 5 or more, so it's going to add to the 8. So my answer is going to be 57.9. If it was 57.81, then it will stay as 57.8. But since I have 7, which is 5 or more, it's going to add on to my 8 to become 9. Calculate the density of the glass. Use your results from A and BI and the equation shown. Okay? So I already know that I have M, 57.9, and I have length, width, and height, 7.5, 2.5, 7.5, 2.5, and 1.3. So if you do your calculation, it's simply going to give you 20 or 2.3. Now this is density, and I have my mass was in grams, and my length, width, and height were in centimeters. So my answer or my unit would be in gram per centimeter cube. Okay, so for part C, the teacher writes down the mass m and thickness t of a single microscope slide on a piece of card as shown in figure 1.4. Here's the thickness of a single slide and the mass of a single slide. Use your answer to BI and information from the card in figure 1.4 to estimate the number of microscope slides and one in the covered stack. Let's go to BI. Oh, the mass was 57.9. I'm just going to write it here so that I can use it. Okay, so I need to find the number of microscope slides in the covered stack. Okay, so my N1 is going to be the entire mass over the mass of a single slide, which is 57.9 over 4.2, giving 13.7857. I'm just going to write it in 3 significant figures. Okay, use your answer to gain information from the card in figure 1.4 to obtain another estimate of the number of microscope slides and 2 in the covered stack. Okay, so I will use this time the thickness, for example. So I'll do N2, which is the height, over T, which is 1.3 over 0.11, which will give me approximately 13. Now, 2 quantities can be considered to be equal within the limits of experimental accuracy if their values are within 10% of each other. State whether your values of N1 and N2 can be considered equal. Support with a calculation. Of course. So I'm going to say, I'll try to find the percentage difference. So I'll do N1 minus N2, which is, I'll do it all in 2 significant figures just to make it right. So I'm going to do 14 minus 13 over 14 plus 13 over 2 and get that in percentage. So 100% will give me 7.41%. Perfect, it's within 10. So yes, N1 and N2 are within 10%. Okay, so just one reason why estimated values of N are different. Well, basically, the answer is because the slides are not all with the same mass. Someone can say that they are not all with the same thickness, since these were the two things that we compared. Well, that's all for this question. Hope you have a lovely day.